Hey guys, this is the fourth lesson for Math 20-2 Angles and Triangles. It's just called Properties of Triangle Congruency, and so this will really lead into tomorrow's lesson, or next day's lesson, for proving triangle congruency. So we just need different properties that are important for it. So this will be kind of a short lesson, hopefully. Full screen, there we go. So there are minimum sets of angle and side measurements that, if known, allow you to conclude that two triangles are congruent. So remember we talked about similar versus congruent before. So congruent means exactly the same. That if I take the triangle and put it on top of the other one, it will be exactly the same. Similar triangles means that they're kind of scaled up or down accordingly, so they have the same angles, but the sides are scaled accordingly. Um, by the same ratio. So that's saying if we have it and one side is doubled, all the other sides will be doubled as well, so scaled up the same ratio. But what we're talking about now is triangle congruency. So saying that if I know these particular things, I can know without any shadow of a doubt that these triangles are exactly the same, that if I laid one on top of the other, they would be exactly the same. So there's kind of three different ways that we will write it. So it says if three pairs of corresponding sides are equal, then the triangles are congruent. So this is known as, I'm going to just call it side, side, side congruence, or we're just going to call it 3S's there as well. So SSS congruence. So we have an example here. This will start making sense once you see a couple of what I'm talking about. So you see I don't have any actual measures. So yeah, I could probably use my little clipping tool and measure this out and lay it on top of this one and see if it's exactly the same. But we know I'm not technologically advanced, so we actually have pieces of information that would help me. So what I see is line segment AC in triangle ABC is the same length as side length XZ. So the way that I know that they're the same, see how this guy has one tick and this guy also has one tick. So since that has the same number, that means those are the same lengths. And then if I look at side length BC, that is the same length as side YZ in the other triangle. And then if I look at side length BA or AB, it's the same as side length XY. So I'm going to just kind of put this into that two-column proof. Let me drag that over, and now I'm just writing. So again, I see that AB, side length AB, is the same as side length XY. And I see, I'm just writing down pieces of information that I was given in the diagram. I already kind of described that to you, but just because we're getting in that habit of using a two-column proof to justify things, we're going to do this as well. I also see that side length AC is equal to side length XZ, and I also see that side length BC is equal to side length YZ. And so for the reasons for this, these ones are nice and easy. What you could do for these is just say that you were given this. We were given the piece of information that this length is the same as this length. We're given that this length is the same as this length. We're given that 1, 2, 3 is the same as 1, 2, 3 on this side. So we're given those pieces of information, but I still want to state them in my two-column proof. And so that always seems silly, but what I find sillier is when we have these questions on a test or something and people write nothing, even though you're given stuff. Always start with what you're given for some of these pieces of information that you have. So these ones are pretty easy for triangle congruency because they're really straightforward. We'll see when it gets more difficult later. But what we have is we have one side length the same, we have two side lengths the same, and we have three side lengths the same. So we have what it says here. It says if three pairs of corresponding sides are equal, then the triangles are congruent. So what our last statement can actually be in this one is we can say, did you guys know like the shorthand for therefore is like those three little dots? That's the universal way of being ultra lazy, and writing therefore as three little dots. So we can say therefore triangle ABC, oh, ABC. If you just write equals, I'm totally fine with that. Usually we represent congruency, like with a little squiggly on top. So triangle ABC is equal to or is congruent to triangle XYZ. And our reasoning for that is going to be, I'm just going to write 3S, it's side, side, side congruence. So since we had three pairs of corresponding sides that are equal, we know that these triangles are congruent. Back. Um, so let's see another one, and then this first one might make a little bit more sense if it's a little bit confusing right now. So the next one says, if two pairs of corresponding sides, so now if we have two sides, and the contained angle, so notice that it doesn't just say one angle, it says the contained angle. So what I mean by contained angle is the angle between those two sides that we know are equal. So if they are equal, then the triangles are congruent. So this is known as side angle side congruence, or SAS congruence. So it's written in that particular order in that it is a side, an angle that's between it, and the other side that's on that. So that's side, angle, side. So again, a side, the other side, and the angle that's in between it. So that's side, angle, side congruence. So it needs to be the contained angle in order to evaluate whether or not something is congruent. So again, I'm going to make my little tiny chart here. So we know side length AB is equal to side length XY. So I'm calling them side lengths. You could call them line segments. Same old thing. I know the angle at B, so I could either write it as ABC or just the angle at B. I'm going to be lazy. Is equal to the angle at Y. And I know side length BC is equal to side length YZ. Let's make it easy. Those are all given pieces of information. So since I have a side, another side, and the angle that's housed between them, we can say that we can say therefore triangle ABC is congruent to triangle XYZ because we have side, angle, side, congruence. All right, so we have SSS and we have SAS. So I know last semester we were joking that snakes for the SSS and sassy allow us to prove triangle congruence. Hopefully you're getting the idea of what's going to happen in a little bit. So the next one is saying if two pairs of corresponding angles and the contained side, so I'm writing that word contained again, contained side are equal, then the triangles are congruent. So thinking about how we're going to write that, so it's saying two angles and the side that's touching both those angles. So we couldn't have two angles, and this side, that's not the contained side. It needs to be the side that's between those two angles. But if we have two angles and the contained side, so again, those angles, these angles, and that contained side, we have something called, again, angle side angle congruence. So it's written in a very specific way. So it's saying an angle, the side in between it, and then the next angle over. So don't write AAS, because that's not actually what it is. It's an angle, the side that's attached to it, and then the angle that's at the other side. So it's a contained side in that case. So looking at this one, we see that with our two triangles, so angle B is equal to angle Y. And we see that line segment or side BC is equal to side YZ. And we see that the angle at C is equal to the angle at Z. Those are all given pieces of information. So what we can say, therefore, since we have an angle, the contained side, and the next angle over, the same for the two triangles, we can conclude that they are congruent. So triangle ABC is congruent to triangle XYZ. And again, that's because of angle side angle congruence. I just wanted to check if I wrote congruent the same way on the last one. I did. So if we have an angle, the contained side, and the next angle, that's angle side angle congruence. So you're all getting antsy because you're like, is there such thing as this congruence? That's a rude word. We can't actually prove triangle congruence by angle side side. I'll show you why in just a second. It's not that I just don't want you to write that answer on your assignments, but we can't conclude that something is congruent by angle side side, and we also can't conclude that it's congruent by angle, angle, angle. I'm going to use this line to my advantage. So you can't do either of these. So last semester, again, we had a funny time with this, that you are not allowed to yell on your test, and you are not allowed to swear on your test. But there's actually a math kind of basis behind it. So just to kind of talk about why those ones don't actually work. So I can show you. Oh, I don't want to press that. Did I already do it? No, I didn't. I take this and I draw a triangle. So if I took that triangle and I copied it, oh, I don't know if I'm going to be able to do this. Edit, copy, edit, paste. Hopefully this is going to work. Okay, so right now, these two triangles should be congruent, right? If I work hard enough, I can get this one on top. So they're congruent right now. And so if I measured their angles, they would have whatever angles. But now if I take this, hopefully it does it the right way, I'm going to scale it up. So if what I actually did is measured these out, we would find that this angle would be the same measure as this angle. And this angle would be the same measure as this angle. And we would find that this angle is equal to this angle. But you can see that those triangles are not congruent. So these would be similar, but not congruent. And so these, sorry, I can write the whole word. So again, this is angle, angle, angle. So we can't use angle, angle, angle because that creates similar triangles, but it does not create congruent triangles. And so the next one is a little bit harder. I kind of have to draw it. Maybe I'll use colors. So now, so that's the yelling. So we don't yell on our test. We can't prove triangle congruency by yelling. we also can't prove triangle congruence by swearing. So I'm going to draw out a triangle. So it's always kind of hard as a non-artist. Nope, I think I need more of an angle than that. Go away, little dot. Go away, little dot. There we go. So hopefully I can make this make sense to you. So I have a triangle, and I'm going to say I have this angle here, and then we have a side length, and then we have another side length. So what this would be, if I had another one, would be an angle, a side, and then the next side. Because what's actually the contained part here is a side. I wouldn't call this side angle side, because the angle is not the contained angle between those two sides. If we wanted sine angle side, we would need this angle instead. So I'm going to just erase this because that's not actually what I'm doing. So right now we're kind of talking about angle, side, side. I can't say it, my kids in the room. So what I could do, if I draw this kind of same triangle, I don't think it'll let me cut and copy it, but if I draw this, and what I'm now going to do is kind of rotate this one side on an axis. Hopefully I can get it to the same-ish length. So what I would have here is an angle. The side length should be the same. I know, since I drew it, it's probably not exactly the same, but hopefully what you can see that I've done is I've just taken this arm and swung it in this way. So I put it at this point instead, so swung it, and it stayed the same length. So you can hopefully see, I can try to draw this again and do it with actual line segments after if you guys need, but all that I've done is I've taken the line that used to be right here and swung it in. And you can see that these triangles are not congruent. They are not exactly the same. So we can't prove triangle congruence by swearing. So not even similar triangles. Those are very different triangles. You can see if I could pick it up and move it over, it would not be at all the same. So again, no triangle congruence by swearing, because you guys are all nice kids and you won't swear on your tests, right? No screaming, no swearing, but you can prove triangle congruence by angle, side, angle. Oh, sorry, I guess I was like, no, can't do that. So angle, side, angle. You can do it by side, angle, side. And if I can move this without messing it up, I can't. Um, the first one being our side, side, side congruence. So that's it, that's all. I don't remember if, let me check, is there questions for today? It looks like there's a couple questions on page 106 for properties of congruent triangles. So we'll see you next day for proving congruent triangles. Thanks.